Welcome to the unknown. Welcome to the new episode of Mystery Connections, the realm where fact meets fiction and reality intertwines with fantasy. Today, we're embarking on a journey beyond the visible, beyond the comprehensible, into the deep, dark abyss of the universe. We are diving into the mysteries of black holes, the celestial beasts lurking in the shadows, invisible yet immensely powerful. They are the devourers of light, the swallowers of stars, the enigmas that defy our understanding of the cosmos. We often wonder, what lies within a black hole? What are their secrets? Is there a possibility of other dimensions, or are they simply cosmic graves where matter goes to die? These questions have puzzled scientists and astronomers for centuries. As we delve deeper into these mysteries, hold on tight, for we're about to embark on a journey of discovery, a voyage into the unknown. Fasten your seatbelts as we unravel the mysteries of the black hole. Have you ever pondered about the darkest, most mysterious corners of the universe? Welcome to the enigma of the universe, where we delve into the deepest secrets of the cosmos. Today, we explore the most enigmatic phenomena known to mankind, the black holes. In the celestial sphere, amidst the glittering stars and radiant galaxies, lurk these invisible beasts, known for their insatiable appetite. Their reputation precedes them, as they are often depicted in popular culture as the devourers of stars, the swallowers of light. These cosmic phantoms have been the topic of fascination, fear, and intrigue for ages. They are the stuff of science fiction, the muses of poets, and the puzzles that keep astronomers awake at night. The more we learn about them, the more they seem to defy our understanding of the universe. So, what exactly is this cosmic phenomenon that has intrigued scientists and stargazers alike for centuries? To comprehend this, we need to journey back in time to the birth of a black hole. Imagine a star, a behemoth of cosmic proportions, burning brightly in the vast expanse of space. This star, much more massive than our Sun, is nearing the end of its life cycle. As it exhausts its nuclear fuel, the star starts to cool and expand, transforming into a red supergiant. This is the calm before the storm, the precursor to a supernova event. The star's core collapses under its own weight, and in a matter of seconds, the outer layers of the star explode in a supernova. This is no ordinary explosion. It's one of the universe's most spectacular fireworks, outshining entire galaxies momentarily. But what's left behind, hidden within the supernova's brilliant facade, is the seed of a black hole. Now, let's delve deeper into the heart of the aftermath. The core, once the star's powerhouse, becomes a battleground for gravity, trying to pull everything inwards, and the thermal pressure, striving to push everything outwards. But in a massive star's death throes, gravity emerges victorious. The core implodes, shrinking rapidly under its own monumental weight, leading to a gravitational collapse. The result? A singularity, a point in space where density becomes infinite, and our understanding of physics, as we know it, breaks down. The singularity is cloaked by an event horizon, a boundary beyond which nothing, not even light, can escape its immense gravitational pull. And thus, a black hole is born. A cosmic beast lurking in the darkness, invisible to the naked eye. An entity so dense, so heavy, that it bends the fabric of space and time around it. A cosmic entity that devours everything that dares to venture too close, from space dust to entire stars. The birth of a black hole is a testament to the universe's grandeur and complexity. It's a process that combines the beauty of a supernova with the terror of infinite density and gravitational force. A process that underscores the volatile nature of our universe, where even stars, symbols of stability and longevity, meet such dramatic ends. This birth process results in an entity with an unimaginable density and gravitational force. Let's delve deeper into the anatomy of a black hole, shall we? At first glance, a black hole might seem like nothing more than a deep, dark void. But it's so much more than that. It's a cosmic entity with a structure as complex as it is fascinating. The first key part of a black hole is the event horizon. This is the boundary marking the point of no return. Anything that crosses this horizon, be it light or a space probe, is forever trapped within the black hole. The event horizon is what gives the black hole its name. It's the point where all light is swallowed up, creating a hole of pure, inky blackness in space. Now, if we venture beyond the event horizon, we encounter the singularity. This is the heart of the black hole. The singularity is a point of infinite density where our understanding of physics breaks down. Here, all the matter sucked in by the black hole is crushed into a point of zero volume. It's a place where the fabric of space and time is twisted beyond recognition. Circling around the event horizon, we find the accretion disk. This is a flat, rotating disk of dust, gas, and other debris that's spiraling into the black hole. The accretion disk is heated to incredibly high temperatures by the immense gravitational pull of the black hole, causing it to emit high-energy radiation. It's this radiation that allows us to detect the presence of black holes in the universe. Each of these components, the event horizon, the singularity, and the accretion disk, contributes to the behavior and properties of a black hole. They work together to create a cosmic phenomenon that's as terrifying as it is beautiful. With such unique components, black holes defy the rules we generally associate with space and time. But how do black holes behave in the cosmic theater, you might ask? Well, let's dive in and discover. Black holes are not just passive space vacuums sitting around waiting for unsuspecting stars to stumble into their gravitational clutches. Instead, they are active participants in the cosmic dance, their intense gravitational pull shaping the behavior of the celestial bodies that reside near them. Imagine a black hole as a cosmic whirlpool. Its gravitational pull so intense that nothing, not even light, can escape once it crosses the event horizon. This gravitational pull is so strong that it literally warps the fabric of space-time around it, as if the black hole is a heavyweight wrestler bending a trampoline. Now, let's talk about one of the most intriguing phenomena associated with black holes: spaghettification. Yes, you heard that right. It's not a word that comes from an Italian cookbook, but rather from the realm of astrophysics. Spaghettification is the vertical stretching and horizontal compression of objects into long, thin shapes in a very strong gravitational field. And it's exactly what would happen to you if you ever had the misfortune of falling into a black hole. The gravitational force at your feet would be much stronger than at your head, causing you to stretch out like a piece of spaghetti. This warping of space-time is not just a theoretical concept. Astronomers have observed stars in tight orbits around black holes, moving in ways that can only be explained by the intense warping of space-time. Even more mind-boggling is the fact that black holes can spin at nearly the speed of light. This spinning motion creates a swirl in the fabric of space-time, much like a spinning top, creating a whirl in water. Through their intense gravitational pull, their ability to warp space-time, and their potential to spaghettify anything that comes too close, black holes play a crucial role in the cosmic theater. Indeed, the behavior of black holes seems more fitting for a science fiction novel than reality. Yet here we are, in a universe where these fantastical objects not only exist, but shape the very fabric of our cosmos. Despite our growing understanding, black holes still harbor many unsolved mysteries. They're like cosmic riddles that tease scientists with their enigmatic nature. Consider the information paradox, a conundrum that has puzzled scientists for decades. When matter falls into a black hole, what happens to the information it contains? According to the laws of quantum mechanics, this information should never disappear. But in a black hole, it seems to be lost forever. This paradox challenges our understanding of fundamental physics, and despite countless theories, it remains unresolved. Then there's the question of black holes and their role in galaxy formation. It's no secret that most galaxies, including our own Milky Way, harbor a supermassive black hole at their core. But what came first, the galaxy or the black hole? And how does the presence of these cosmic monsters influence the birth and evolution of galaxies? These are questions that scientists are still grappling with, trying to piece together the cosmic puzzle. And let's not forget about wormholes. These hypothetical shortcuts through space-time have been a staple of science fiction, but could they be a reality? Some theories suggest that black holes could be connected to others via these wormholes, creating a network of cosmic shortcuts. But as tantalizing as this idea is, it remains purely speculative. In the realm of black holes, even the most basic questions can open doorways to new and unexplored territories of thought. They challenge our understanding of the universe and push the boundaries of our knowledge. They are cosmic enigmas waiting for the right mind to unravel their secrets. These unsolved mysteries make black holes a hotbed for scientific exploration and discovery. Each question leads to another. Each theory opens a new pathway of thought. Who knows what secrets we'll uncover as we continue to delve into the mysteries of these cosmic giants. One thing's for certain though, the journey of discovery is as exciting as the destination. And when it comes to black holes, the journey has just begun. Today, we have journeyed through the birth, anatomy, behavior, and mysteries of black holes. We have seen how these cosmic giants originate from the explosive death of massive stars, leaving behind a gravitational field so strong that not even light can escape. Their anatomy, a dizzying concept of an event horizon, a singularity, and a point of no return, further emphasizes their power and enigma. We've delved into their behavior, their ability to warp and manipulate time and space, to consume yet also to create. And we have pondered over the mysteries yet to be solved, the enigmatic black hole information paradox, the nature of the singularity and the tantalizing possibility of other universes lying beyond the event horizon. Black holes are indeed one of the universe's most intriguing phenomena, a testament to the wonders and complexities of our cosmos. As we continue to gaze into the cosmos, we strive to unravel the mysteries that black holes hold, one scientific discovery